Okay, so the question says, dogs come in many shapes and sizes. In order to buy a proper fitting harness for a dog, the owner must measure the pup's girth. Below is a table showing how many dogs live with their owners in apartments, condos, one-story homes, and two-story homes. Of those dogs who live in a one-story home, so I know I'm looking at the one-story homes. What percentage is closest to the dogs with a 29.1 to 35-inch collar? So it's 47. How many total live in one-story homes? Did anyone add them all up? 222. So Ayana added 37 plus 39 plus 42. She added up all the one-story homes, so she got 222. Because it says not of those dogs who live anywhere. It says of those dogs who live in a one-story home. That's why she knew to add up all the one-story homes. So we have 47 out of 222, and when you type that in your calculator, you should get a decimal. What decimal did you get, Ayana?
0.2117.
So that's how she got 21%. That's how she got 21%. Now, Ayana is very smart. I'll give her that. But I would have guessed Ayana's answer anyway. Why, if I was guessing, would I have guessed Ayana's answer? A is 21 backwards. 12, 21, I feel like they're pointing straight to that. 12 is a little small. The other answers are larger than that. So if I was guessing, I would have guessed B, 21 anyway. Are there any questions about that one? Okay, then get out your notes. So the great news is we're on Chapter 8. The not so great news is that there's so much to learn in Chapter 8. We're going to take a quiz this Friday on one thing, and we're actually going to take a test. Instead of doing 3 sections test, we're going to do 2 sections in a test. There's that much stuff in 2 sections worth of notes. 8.2 and 8.3 are happening sections. In fact, we're going to probably be on 8.2 at least today and tomorrow, maybe today, tomorrow, and the next day. That's how important 8.2 is. It's going to take us a couple days. Okay, hopefully you've already heard the Pythagorean theorem. If not, this is the thing Harrison is going to memorize tonight if he doesn't already know it. It's a squared plus b squared equals c squared, just like the alphabet, A, B, C. A squared plus b squared equals c squared. Now we're about to talk about what letter needs to be A, B, or C, and how to plug stuff in and how to solve. But the most important thing Harrison needs to remember is what's in parentheses right here. It only works on right triangles. You cannot try it on a triangle that is not a right triangle. It will not work. It only works on right triangles. Okay, so there's only one rule. It doesn't matter which number you plug in for A, which number you plug in for B. The only thing that matters is what you plug in for C. C has to be the hypotenuse. And if you're trying to figure out where's the hypotenuse, well, that's easy. If you can find the right angle, across from the right angle is always the hypotenuse. Always the hypotenuse is across from the right angle. So in fact, that's what I'm going to go ahead and do on my first 4. I'm going to go ahead and draw the arrow. So I know my hypotenuse in number 1 is x. My hypotenuse in number 2 is 12. My hypotenuse in number 3 is 15. My hypotenuse in number 4 is x. So that means when I do number 1, instead of doing c squared, I'm going to do x squared. When I do number 2, instead of doing c squared, I'm going to do 12 squared, etc. Okay, so the only reason this is going to be slightly difficult, so I always write the formula, a squared plus b squared equals c squared. So the one rule is that the hypotenuse has to be the c. So in our case, the hypotenuse is x, so it has to be c squared. X squared has to be c squared. It does not matter if Jennifer does 4 squared plus 7 squared, or if she does 7 squared plus 4 squared. It does not matter which one she picks for A or which one she picks for B. It only matters who she picks for C. Okay, what is 4 squared? 16. What's 7 squared? Okay, 49. So 16 plus 49 equals x squared. What is 16 plus 49? 65. So 65 equals x squared. And this is the only part that gets confusing besides the who's the hypotenuse. How do I get rid of that squared? Take the square root of both sides. So I'm going to have the square root of 65 equals x. This is what I want from Kevin. I do not want a decimal. This is what I want from Kevin. Now, if Kevin got square root of 64, is that what I would have wanted from Kevin? If the answer had been square root of 64, would Kevin circle it and say, that's it, I'm done? No, he would not get all his points. What is the square root of 64? 8. So Kevin would need to go one step. But we don't know the square root of 65, and we can't simplify it nicely. So we're going to move along. Okay, so number 2, I write my formula, a squared plus b squared equals c squared. Pierre, how do you want to plug this in? You choose.
X squared plus a squared.
Perfect. If Jackie wants to be different and do 8 squared plus x squared equals 12 squared, she's still going to end up at the same answer, as long as Jackie and Pierre are all using the hypotenuse for the c. Okay, so x squared plus 64 equals 144. If I subtract 64 from both sides, I get x squared equals something. Is it 80? Okay, so if I take the square root of both sides, I get x equals the square root of 80. Now, here is where Kevin runs into trouble. Kevin, if he leaves it at square root of 80, he's going to miss probably 2, maybe 3 points on the test. So, Kevin, every problem, he's down to like a 97, a 94, a 91. So, if Kevin's not wanting to do that, he needs to simplify the radical if he can. I need two numbers that multiply to give me 80. We've done this before in bell ringers. It was a while, but we've done it before. 10 times 8 would work, but I would love if one of them was a perfect square. Is either 10 or 8 a perfect square? No. So I need something else that multiplies to give me 80. The largest perfect square you can come up with would be nice. 4 times 20 is going to work, but there's a bigger perfect square, because 4 is a perfect square, but there's a bigger perfect square that goes into 80. I only know this because 16 times what? The only reason I know these so well by heart is because that's all I do in Algebra 1 lately. It would take you a few minutes playing on your calculator to figure out which one to do. I think I've told you this before. That's what I tell my algebra kids all the time. They get a divorce. I'm sorry. It happens. They live in separate houses. And then I know what the square root of 16 is. It's 4. I don't know the square root of 5. So my answer is 4 square roots of 5. This is what I'm looking for from Kevin. If Kevin leaves it at square root of 80, Kevin's going to miss out on some points. And so, you know, once I finally finish talking today, I'm going to hand Kevin a work. It's not even a worksheet, it's a puzzle. But the answers are going to be reduced radicals like this. So if Kevin can't go from here to here, he's never going to figure out, like, did he do it right? Because he won't know if this puzzle makes any sense. Hopefully he can. Okay, someone from, let's do Harrison. Harrison, how do you want to set up the next one?
15 squared plus 9 squared equals.
Why did she give you a look? Tell him why you gave him a look. You're right. Tell him why you gave him the look. Oh, thank you. 15 is the hypotenuse, so it has to be c squared. Okay, so since you're taking over, do you want x squared plus 9 squared or 9 squared plus x squared? 9 squared plus x squared, she said. Okay, so if Harrison did it his way, no offense to Harrison, he's going to get it wrong, so he's not going to do that. 81 plus x squared equals 225. If you think he's not the only one who wants to always make the x the c, he is not. It happens all the time. If I subtract 81 from both sides, I get x squared equals, I don't know, 144? Oh, perfect. So if I take the square root, I get x equals square root of 144. If this is Kevin's paper, does Kevin circle this answer? Kevin wants an A. It can to what? Because the square root of 144 is 12. So he's going to put x equals 12, and that's what he will circle. Okay, and then the very last one, let's let Michelle. Michelle, how would you like to set up number 4? Perfect. Okay, 5 squared is 25, 8 squared is 64, so 25 plus 64 equals x squared. I get 89 equals x squared, so I need to know the square root of 89, and that equals to x. I'm trying to think, I shouldn't have written pink. Let me zoom in on that. I tried to think what multiplies to give me 89, and I can't come up with anything. Does anyone know anything that multiplies to give you 89? I can't think of anything. So I think that is the answer that Kevin wants to circle. But again, if Kevin can figure out how to reduce it, he should. He wants all his points. Okay, are there any questions about this? Let's talk about this thing at the bottom. And let's talk about what I need from you. Hold on, let me look at the back. Oh. We'll come to that in just a second. Let's talk about this thing at the bottom. Okay, so let's face it. Jennifer does not have all day. I'm about to hand Jennifer a ton of these problems. She does not have all day to calculate this every single time. Is there a pattern that happens? There is. It's called a Pythagorean triple. For instance, the most common ones are in bold. 3, 4, 5. 5, 12, 13, 8, 15, 17, and 7, 24, 25. If Catherine were to check me, 3 squared plus 4 squared, does that equal 5 squared? Well, let's see. 9 plus 16, does that equal 25? Well, yeah, 25 equals 25. Thank you.
Would you like to go to this? We have money to pay.
Yeah,
It's on a Friday.
I'd like to.
Okay.
Okay.
It's the April 7th.
Okay.
Calendar.
Uh-huh.
All right.
Got it. Okay, so awesome. That sounds like that sounds awesome. Thank you. Okay, so you see how I plugged in 3, 4, and 5 and it all worked out? If I plug in 5, 12, and 13, it'll all work out. It's 8, 15, 17, and 7, 24, 25. If you learn those 4 triples, 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, then you don't actually have to work out any problems, because what's going to happen is you're going to get a picture and it's going to have 3, 4, and it's going to have an x over here, and Catherine's just going to write x equals 5 because she knows her triples. It's going to make our life a lot easier. Now, everything else under there, you don't have to memorize, but notice they're all multiples of that list. So if you learn 3, 4, 5, then notice 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. This is 3, 4, 5 multiplied by 2. 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. This is 3, 4, 5 multiplied by 3. So if it's a multiple of a triple, it's still a triple. Okay, well, I'm going to keep saying these 4 over and over and over again. What? I don't even know. I'm going to keep saying these 4 over and over and over again. On Friday, I'm going to hand you a quiz. It's going to have a list of options. All you have to write, like if you see 3, 4, 7, no. 3, 4, 5, yes. 5, 15, 36, 39, yes. 16, 30, 34, yes. 5, 12, 14, no. I just need a yes or a no. Now, what would be smart of Ayana is she could always check it. If Miss Compton said 5, 12, 14, well, she could see if 5 squared plus 12 squared, is that really 14 squared? Obviously, she's going to figure out it's not. 25 plus 144 does not equal 196. It's not going to work out. So she can figure out that's not true, so that's not a triple. But I'm only going to give her so long. Because otherwise, Ayana could do this on every single problem, and then I'll never know that she actually memorized the 4 that I wanted her to memorize. So it's going to be a time triples quiz on Friday. Okay, flip over to the back. Come in. Yes, I can. Thank you. Okay, so without actually having to do 24 squared plus n squared equals 26 squared, how can I instantly know the answer to this problem? Apparently, it's Pythagorean triple. So flip to the front. Do you see a 24, 26, and some other number on the combo? You can look at the chart today. Flip to the front. Look at the chart. Do you see 24, 26, and some third number on the chart? No?
Yes.
I do. I see it on my chart. Kevin, stop saying silly things. I'm over it. Do you see it on your chart? I see it right here. So I know x is 10, and I'm not actually having to calculate squat. Okay, number 6 is the same way. It says 36, 39. Look at the front. Look at your chart. What should I put in for x? What is it? 15. Okay, let's see that Ellie's not crazy. If I flip over to my chart, 36, 39, it is 15, 36, 39. Again, if Ellie just learns the top bold ones, she'll know all the multiples of those. Okay, because let's face it, Harrison's smart. He realizes 24 is a nice number. He knows 26 divided by 2 is 13. He knows 24 divided by 2 is 12. If he memorized the 4 I asked him to memorize, he knows 5, 12, 13. Well, 12 times 2 is 24. 13 times 2 is 26. So 5 times 2 is 10. That's why Harrison only has to memorize the 4. If Harrison understands multiples, then he can figure this out. For instance, on this one, let's see, 39 divided by 3 is 13. 36 divided by 3 is 12. Oh my goodness. I see a 5, 12, 13. So since I was dividing by 3, I need to multiply by 3. 5 times 3 is 15. They're all multiples of the top 4 bold ones. If you learn the top 4 bold ones, you're good to go. Okay, and then we're going to work one of the ones at the bottom. We won't work number 8. We'll just work number 7 so you can have a little time to work on your worksheet. It says a 20-foot ladder is placed against a building to reach a window. So here's my ladder, placed against my building to reach a window. I'm not a good drawer. That is 16 feet above the ground. How many feet away is the bottom of the ladder? So really, they're giving us a triangle. It is a right triangle. The building is how many feet tall? How tall is the building? Is the building 20? Okay, so where do I put the 16? Do I put the 16 on the hypotenuse?
No.
Where do I put it? Do I put it down here? You put it over here? Okay. Where do I put the 20? Next to the ladder, and then I'm going to put an X here because I don't know it. Now, Ayana can either work out x squared plus 16 squared equals 20 squared, and she can solve, or she can do what Ellie's doing and try to figure out a triple. What number goes into 16 and 20? 4. So what's 20 divided by 4? 5. What's 16 divided by 4? 4. So it's actually a 3, 4, 5. So what is my final answer? Is it 3? I divided by 4. Divided by 4. So don't I need to... Yes, because 12 divided by 4 is 3. So x equals 12. If you don't know how I did that, could you still work this out? I don't... What's 16 squared, Ayana? Figure that out for me. 400 minus 256. I still get the same answer as Ellie, but my gosh, this required a whole lot more work than what she did. If you knew the triple, you don't have to do anything. And on the test, if Ayana just wants to put PT because she knows it's Pythagorean triple, that's fine with me. I know that she's worried about showing work because this is math class, but PT, it's fine with me. Okay, I'm done ranting for today. If you have any questions, let me know. Otherwise, I'm going to hand you this worksheet. It is not due to